Good morning, everybody. Welcome back to lecture number 13. Today, I will give you some bad news. We have two bad news. Bad news. One, we have Supermesh. Two, we have Supernode. I will explain the concepts now, but we will solve the problem at the beginning of the help session. We will try to solve the problem, stop the recording, نروح نصلي العشاء, we come back, we continue the help session. So that we will have two recordings, one for Supernode, Supermesh, one for the help session itself. Okay? Any question in the material before we jump? So, regarding the Supernode, which I will begin explaining, if you go all the way at the end, and yes, we did update the slides, the concept of a supernode that's why I do PDF. Slideshow, it will restart. So supernode node voltage method is a special case where we reduce the number of nodes in the above system from two nodes, you have now here V1, V2, to a one giant supernode. This is what we did before indirectly. If you look at supernode 2, for example, what's the voltage at V3? It's minus 15. Before I told you, we already know V3, we do not need to calculate it. In reality, what we are doing, it was a supernode, but I did not tell you it's a supernode. So if you have a voltage source connected to the ground, you do not need to calculate V3. Right now, you have a giant supernode where you have the voltages to be, you write the equations. For example, you call it V minus 0 over R2 plus V minus R1 plus V minus V3, and then at the end you add V1 minus V2 equal to minus 10, because V1 at the negative, V2 at the positive. Okay? Let me re-explain it again. It is already known that V3 is minus 15 volts, because the battery is minus and plus 15. When you have V1 and V2, you solve them, you write the equations as 1 KVL, one equation, V1 minus over R2 plus V2 over R4 plus V1 minus V3 over R1. And then you add another equation, so you have two variables, two unknown. The other equation is V1 minus V2 over 2. So how to write this equation? You will have basically V1 over R2 plus V2 over R4 with minus 0, plus V1 minus V3 over R1. V3 is, you already know it's minus 15 equals 0, and then you write V1 minus V2 equal minus 10 volts. So two variables, two unknowns, put in the standard form, and then you solve it. Hopefully we'll try to do it in the help session, an example. Any question about the supernode? Yes?
That's the main difference between the supernode and voltage node.
Well, it is a node voltage method.
But the supernode, there is a current source. There's a voltage source.
With the supermesh you're talking about, yeah. Supermesh, there is a current source in the middle. Now, because right now you cannot calculate the current that moves from V2 to V1 or from V1, ما في مقاومة هنا. We say let's create a big supernode and write KCL 1, 2, 3 currents. IA, IB, IC. Equation 1. Equation 2, V1 minus V2 or equal to minus 10, or you can say V2 minus V1 equal 10, right, Hatem? You will come to the help session today? Inshallah, good job. Okay, Supermesh. Now, Dr. Atiyah, he's the one who's writing the exam. I wrote some questions. The questions that I wrote, I think 4 of them were easy, 2 require some work. Because we cannot make it very easy. It's KFUPM, okay? The Supermesh, do you remember this ugly circuit? We all know it, right? The ultra checkpoint. In the ultra checkpoint, we have, I told you to create one loop here, so you will have voltage rise, and then you put plus minus. Now you notice in homework 2, we had problem 8. If you stick with my method, you get the nice answers. Even the TA, when he gave me the solution, he made a mistake. He forgot the passive sign convention. So those who did solve problem 8 in the homework or the quiz for the other section, not you, you got the passive sign configuration right. So what did I tell you about this problem? It's very simple. You create 2 equations. You create around loop 1, I call it L1, and around loop 2. This is loop 2. In loop 2, you're avoiding the current source. So equation 1 will be what? 17.4 minus 40 times IA minus IC minus 15 times IA minus IB. Equation number 2, it will be voltage rise, so it will be 15. I told you, do not change the polarities. Stick with my method. 15 times IA minus IB plus 40 times IA minus IC minus 26 IC minus 10 times IB, because it's a voltage drop. And then if you put plus minus 4 times IB equals 0. The last equation will be what? IB minus IC equal, well, not 10, 0.1. Equals 0.1. Okay? Get it? So we will try to solve it as a warm-up exercise for the health session. Any question about the Supermesh and the Supernode? Well, we have to catch up with the material, so I need to start chapter 3, which is not included in the test. If you don't want to pay attention, the door is open. Okay? That's okay.
No.
I'm not going to be offended, ya shabab. I want you to be happy in the class. So, what is a capacitor بالعربي? مكثف. What does كثف, فعل كثف mean? Condense. So in the winter, your windshields, there is a humidity, they condense the water. So basically they store the water. So what does capacitance in electrical engineering mean? You store electricity. So a capacitor is a storage element device. And the way they design it is they have usually 2 plates made of metal, and then they insert here a dielectric material. And then you studied in the physics the dipoles. Di means 2. Poles. Dipoles. We're engineers, we're not physicists. The way it works is if you apply a voltage, the electrons tend to be stored inside the dielectric material. How does that work? Well, Before we start, let me tell you what we're gonna do. We're gonna find the current for a capacitor or inductance given the voltage as a function of time. Basically, we'll be dealing with integration, taking derivatives, etc. We need to compute the capacitance of parallel plate capacitors, compute the energies stored in capacitances. So those are some shapes of the capacitor. This is cylindrical. This is cylindrical. هذا زي العدس. These one are square. So those are capacitors. Inductors, اللي هو inductor is a copper that's looped into a circle. Why it's moved into a circle? Because of the right-hand rule. It creates a magnetic flux that will create a magnetic flux going here, so the electric current will move across the cable. And this is the basic operation of what we call induction motors.
And wireless charging.
Wireless charging has another application. The one in the iPhone here, this is an inductor, circular inductor. This is a very good application where inductors. Now for you, what did I tell you? A cheat code. If you're a mechanical engineer, you want to benefit from this course, you definitely want to try to explore electric vehicles. Definitely. I'm pretty sure half of you, they have Mustangs. Who has Mustangs? None? They're not mechanical engineers. They're fake mechanical engineers. Well, if you have a car that makes a noise, you tend to have motors. Mechanical engineers, they enjoy studying electric motors because it involves movement of the rotor. And the electric motors are actually nothing but inductors that are shaped in a very specific way so that the magnetic fields rotate. When the magnetic fields rotate, they create a torque that will spin the motor. This is a very important. Physics 102 is I think, more useful than what we thought. Okay? Then you have variable inductor, ferrite core inductor, multi-layer ceramic inductor, etc. Do you all remember the cars that if you put a battery, it moves? So the battery, it creates a magnetic flux and then this motor would spin. This is a very simple example. So resistors, they convert electrical energy into just what? Heat. They're just heat. If you touch the lab, the resistor in the lab, what will happen? It's warm, صح? And some of you, they even caused fires during the experiments. I'm not going to mention names. Some of you connected the 10 volt in a very small resistor. What happened? So much current flow and you got heat. And the heat in the resistors, they reduce the lifespan of the resistor. Two additional circuit elements, inductors and capacitors, not in the exam, today's exam. Major two. Inductors and capacitors are energy storage elements. They can store energy and later return it to the circuit. So they have the ability to store and then discharge, etc. Capacitors and inductors do not generate energy. Thus, like resistors, they are said to be passive elements. If you bring a capacitor by itself and you put it in your tongue, it will not burn your tongue. If you put a battery, it will burn your tongue. So an actual capacitor or an actual inductor do not have electricity in them. They will not have electricity unless you connect them with a battery. Question, superposition. Can we use superposition for inductors and capacitors?
No, because
Why?
they are not linear.
They are nonlinear elements. So what does nonlinear mean? Well, nonlinear, in math, they either have terms like x squared, x to the power 1 over 3, etc. Or they have what? Derivatives. dv, dt, integral of I. Those are nonlinear characteristics. Or they have exponential. e to the power x. Or they have sine and cosine. I don't think there is another nonlinear element. It's either mathematical or integral. So we're going to see some features. Derivatives and integration, they're crucial. Why? Because they're storing. Storing means what? Keep adding. Keep adding means what? Integrate. So you cannot use superposition here. That might be a question in the test. Capacitors are constructed by separating two sheets of conductor. So you have conductor plate. You already studied that in physics 102. And then we have a dielectric material. The circuit symbol, two circuit symbols we're going to use. Either we use two straight plates or one straight and curly. What is the difference? The difference, of course, if you notice here, the negative and the positive, the negative is toward the arc. But in reality, there are capacitors that are unidirectional. It means you have to connect it in the lab, plus and minus, according to the arrow drawn. And in the actual capacitor, they're going to draw a line telling you which part is the negative. If you reverse polarity and you connect it to the higher voltage, you will burn it. There is also other capacitors that are bidirectional. You can connect it this way and you can flip it. Like the resistor, you can flip it. So if you see in a diagram a capacitor like that, you have to be careful. Get it? So the arc means negative. And of course, as any other element, we try to measure V of t, I of t. Why we said V of t and I of t?
It's a function of time. It's not constant.
So from now on, if you apply a DC voltage on a capacitor, that's a question in the FE exam. Who wants to do the FE exam? Raise your hand. Fundamentals of Engineering. It's the first exam after the undergrad. Maybe you do it 1 or 2 years after you get a job. They're going to ask you, question. Oh, if you connect a 5 volt to a resistor and a capacitor, what is the current I? Well, 5 volts, DC, capacitor doesn't work with DC, it works on AC. So that capacitor will act like an open circuit, so no current will flow. It's DC. So we have to vary it with time. If you connect it to a DC, it will just store whatever 5 volt. Store it. And if you remove it, we're talking physics. We're not talking electrical engineering. Physics, they study what goes inside the capacitor. Electrical engineering, what goes to the system if we connect a capacitor. There is a YouTube video. Can you watch it? Can you all watch it at home? Please watch it, okay? You can read this article. Are you familiar with the storage tank? So capacitor is the EE version of storage. You keep filling it with water. The more water you have, the higher the pressure, then it will increase the flow. So the current will vary over time. YouTube again, another video you have to watch. Store the charge in terms of voltage. Now, it's boring, we don't solve problems, so today's lecture is easy. Take it easy. I know you're worried about the test. I told you those two plates, they store energy inside the dielectric. What is the equation that tells me how the storage is governed? Well, Q equals CV. Easy equation. C is the value of a capacitance. What's the unit of a capacitance? Farad. Capacitance is measured with the unit farad. And I want to tell you, 1 farad is so huge. In the electric circuits, expect to see stuff like 1 micro, 2 micro, 1 millifarad is also huge. 1 farad is a very big capacitor, bigger than this room, or maybe as big as this room. But small capacitors that are used in electronics like the camera, they're like in the microfarads. So if you solve a circuit in the test, measure 2, and your answer comes with 1 farad, you should say, oh, something is wrong. Okay? The constant of proportionality is the capacitance, which has a unit of farad, and it's equivalent of coulombs per volt. Coulombs equal farad times volts. You have to know this equation. You have to understand it, that in order for us to increase the amount of electrons stored, we either have to increase the capacitance or increase the applied voltage across the two terminals. Get it?
So
Yes.
can we use a capacitor as a battery?
Well, it is used as a battery in many applications. When you apply a voltage across it, it will store energy. If you remove the battery, it will still hold that energy that can be used to discharge electricity. But it's a limited battery. Has a limited time. Why? Because the charge decreases exponentially. Physics 102. Okay?
So what's its applications?
Well, there are many applications for capacitors. One major application, if you are familiar with the radio. So the radio devices, the one that you use to communicate, the capacitor and the inductor, if you change the variables, you can tune into a certain frequency. To tune the frequency, the product of the LC circuit has to match the frequency. That's why I told you it's AC. It's operated with AC. Its main benefits is with AC. Very few benefits if you connect it with DC. Basically, you have to use it. Another application is the amplifiers. Another, like the speakers of the car. They have to put it to increase the quality of the volume. Another application in big capacitors in power systems, they use to increase the voltage of the grid. So for example, if you have a distribution line, here is a line, let's say it's 100 kilometer. If you send a voltage of 115 kV, maybe here it will go down to 90. If you connect a capacitor bank, this 90 will actually be elevated back to 115 kV. This is one real life application. So capacitors, think of them as they boost your voltage. In power system, in communication, they tune the frequency. They eliminate unnecessary frequencies, filters, for example. If you have a frequency you don't want to hear, you can block it using RC circuits. Okay? Okay, sorry. Dr. Atiyah just sent me an announcement. There was a question if the major exam will include conceptual questions or it will focus solely on circuit. The answer, he said, anything. Bad news. Okay? Expect anything. It's gonna be a fun major exam. بنلعب هنا في الأرض حقتنا ملعب 59. It was at building 24, I told you, but we wanted to do the game here على الملعب. End of the corridor. 4 classes. You will be distributed randomly. We'll share the list of IDs. Okay, any question? Okay, there is another important equation. What happens to the current? Well, whatever scientists in physics, they did some experiments and they realized that the current that goes through capacitor, it's actually related with the rate of change of charge, and this matches the definition. So what if we substitute Q equals CV in the same equation? You remember, we told you before, chapter 1, maybe first question in the test, I equal what? dq dt, right? But Q equals CV. So you take that, so it's dCV with respect to time. C is constant, right? So take it out from the derivative. So C times dV dt. If the current enters from the negative, passive sign convention. If passive sign configuration. What is it called? Passive sign configuration? Then what we have is it's -2, all of it, is Q equal minus CV, no, not Q, I equal minus C dV dt. So how many times now we have passive sign configuration? Power. V equal IR, Q equal I equal C times dV dt. In the test we have only two. Passive sign configuration. فتح عينك في الاختبار. إذا التيار يدخل من السالب في هالحالتين فقط تحط سالب غصب. ما لها دخل في voltage rise و voltage drop. Two different complete stories. تمام؟ Let's do a simple example. Suppose that the voltage is this DC or AC?
AC.
Is it alternating current or direct current? It is alternating because the voltage, not current, the voltage changes its value over time. It's not like the battery, 5 volt all the way. Okay, Hatem? Is this DC voltage or AC voltage? This voltage over time, is it DC or AC? Is it alternating current or direct current?
I remember it in the first slide. AC.
You're right. So that's an AC, right? So, Q equals CV, you just multiply the whole figure by C. So if you notice, 10 times 1 micro. What is micro? 1 times 10 to minus 6. If you use MATLAB, 1e minus 6. This is MATLAB. If you use Python, any software engineers?
X minus 6.
Something like that. I don't know. You figure it out. But I care about MATLAB. Do you know how to plot this in MATLAB? Do you know how? If we have time, we'll try to do some MATLAB. So you just multiply 10 to minus 6, so you keep the same curve, but you change the unit here to micro, so 10 micro instead of 10 volt. Clear? In the homework, we might ask you to plot it using MATLAB. Why? Because I want you to learn. We're not going to do it by hand. Now, suppose that the voltage is the same, is applied to the 1 microfarad capacitance. Plot the stored charge and the current through the capacitance versus time. We already plotted the charge. How about the current? Well, the current is nothing but, what's the equation? I equals C times dV dt. Or you can see it's dq with respect to time. So you can either find dq dt directly or get the voltage curve and take the derivative of it and multiply it by C. Which one is easier? Well, I think it's easier to get the Q plot. So we want to take the derivative of that plot. From 0 to 2, what's the slope?
5.
10 over 2 is 5 micro. So here, well, here the time is in microsecond. So we divide 10 microcoulombs over 2 microseconds. The micros will cancel, that's why you have 5 amps. So between 0 and 2, you have 5 amps. The micro in time cancelled with the micro of the charge. Get it? Between 2 and 4, it's DC, right? If you only look at that time, it's direct current. What's the derivative? 0. How about this one? It's a negative line, so it is 10 minus 0 over 4 minus 5, which is going to be minus 10. Any question about how to find the derivative? Well, that's current in terms of voltage. Okay, if I tell you I equal minus C dV dt, can you write V as a function of I? Yeah. So V would equal to, you have to integrate 1 over C. I'm not using the passive sign, I'm using this equation. I'm not using the one with the negative. You have to integrate I dt. That's it. Because if you take the integral for both sides, the integral will cancel. This is a common trick in physics or mathematics. If you solve this equation, you have to not to forget about the initial conditions. So to get the charge is actually the integral from T naught to T plus the initial charge that was already stored. Sometimes the initial charge is not 0. Sometimes it might be 1 column already stored. So you have to familiarize yourself with the initial conditions. So to fix this equation, we need to fix the limits from T equals 0 to T naught, and we need to add what? The initial voltage. Sometimes the capacitor has initial voltage if it was storing some element. Same for the current. What's the equation of the charge? Is nothing but you do the integral from T naught to T of I of T dt plus Q of T of 0. Note that the equation is Q equals CV is still valid, and that's how we found the voltage equation. Suppose that we know that the current IT flowing through a capacitance C, we want to compute the charge and the voltage, we use these two equations. How to use this equation? It's very simple. You do integral. So let's say you have I of T equals 1 over 2 sine 10 to 4 times T. Question, what is the unit of 10 to the power 4 times T?
10K.
Well, the unit is radians. So what's the unit of 10 to the power 4? Is radians per second. What's the unit of T is seconds. So second will cancel second, so this is in radian. Math 002. If you do the integral, what is the integral of that? If you do the integral, what is the integral of a sine? And then there's a half outside. 10 to 40. It's 1 over 2, and then I think you need to divide by
10 to power 4.
1 over 4. So 1 over 2 times 1 over 10 to power 4 times minus cosine of the same number, right? And then you do it across the limit of 0 and t, right? So it will be 1 over 2 is going to be 0.5 times 10 to minus 4 times minus cosine 10 to 4t, and then cosine of 0 is what? 1. So it will be minus 1, so it will be plus 1. And it's the same. And what's the unit? It's coulomb. This is the charge. So this is Q. What is V? V equal, you take the whole number, Q, you divide it by C. So you just divide it by C. And then you will get another number, which is 500 times 1 minus cosine 10 to the power 4. You divide it by 10 micro, right? So you'll have 0.5 times 10 to minus 4 divided by 10 times minus 6. Is it 10 micro?
Yes.
No, 0.1 micro. 0.1 micro. And then times that equation, which is 1 minus cosine 10 to 40. We have 10 minutes. MATLAB. Well, do you want MATLAB? Do you want me to teach you some MATLAB? Why not? Class is boring. You go to the website. What's the website? MATLAB.mathworks.com. You already have a free version. You don't need to download the app in your computer. Sign in. Put your email. Put the password. You can open MATLAB online, right? Yes. So if you open MATLAB online, basically that's the actual software on the web. You can do it with iPad, you can do it with anything. It's hard. So I'm writing here a code. In the homework, you may need to do it, so focus, okay? In the first line, line number 2, do you see the line?
Yes. Yes.
Or you want me to make it bigger? View. Not view.
Zoom in.
Zoom in.
Not zoom in. There's another way.
Double click.
No, there's a setting. Preferences. You go to the editor. And then you go to whatever. I'm going to search for font. Font 10, let's make it 18. Is this readable?
Yes. Yes.
So the code now is 10. So you start with the command CLC,
Yeah.
means clear whatever terminal. Clear all means clear all variables stored. Close all means close all figures. Then you create a time vector from 0 to 0.5 seconds with the steps of 0.01. So you will have 0, 0.001, 0.002, no, 0.01, 0.02, 0.03, all the way until 5. So how many samples? 5 minus 0 over 0.01. Do the math. Plot. You write the equation, I of t is 0.5 times sine. You have this in the homework, you would have it. Sine of 10 to the power 4 is actually 1e4 times t. So this will create the same vector of the time for the current. Then you plot x versus y. T is time, I is current. Then you create the charge, you write the equation of it, then you plot it. If you want to do some advanced stuff, you can explore what we call the symbolic variable. The symbolic variable, well, that's hard. I can't make this larger. It's hard. Well, I messed it up. But anyway, the symbolic variable creates symbolic variables, and there is examples how to do it. For example, if you get stuck, always view off, no, top button, left, right, top button, off. Just close it and reopen it. I messed it up. Hopefully it doesn't. Hopefully it goes back. لازم ترجع. Well, I really messed it up. Can't get it back.
What's happened?
Well, it's not that straightforward. Minimize. Yeah, whatever. If you use, for example, sims I, then you can use the command integral of let's say I for x from 0 to 1. I don't know if it works or not.
First we should put the function after that.
Yeah. Anyway, you have to create symbolic variables. So you can write sims, and then you can say time, okay? And then I equals, let's say, sine of t. And then you do integral of time of I with respect to t from 0 to 1. And then it will must be a function handle. Well, can use sine of t. You figure it out yourself, but that's the key, okay? That's what I want you to do in the homework. If we ask you to do MATLAB. Get it? So now you have access to MATLAB. Do you know how to do it? Symbolic variable?
I think I can do it.
Well, what is the order? Integral of what?
I think function, after that the independent variable, then the limits of integration.
But we did the function sine of t.
Did we define t as a symbolic?
Yeah.
That's why I asked t.
Since t.
Then let's say I of t. I open parentheses. No,
You have to open parentheses? No, you can't.
this is
open
how I used to do it.
No, you can't open parentheses in MATLAB.
Like
Yes,
that.
you can.
Equal sine of t.
Okay, let's make it simple. Oh, you're right.
Then int, I think.
Int? Only int?
Yes.
Sine of t?
No, we can just put I or sine of t.
As a function of t? From 0 to 1. You're right. 1 minus cosine. Thank you. Plus 0.5 in the whole class. So who had the bonuses now in this class? Only you? You only the other class you have one has a 0.1, the other has 0.5. 0.5. Remind me at the end of this. If you need it, if you don't need it, leave it. It's a matter of halaf. If you need it only. Okay. You know how to do integration? Good job. Thank you. For passive configuration, power equal V times I. And when I say V times I, what we have is, of course, if it's in the current enters from the negative, the power is negative. So you apply the same equation, CV dV dt. If you do all the equations, you will. Now, energy is the integral of power. Energy is the integral of power, which is CV times dV dt. dt will cancel with dt. Then you will have the integral from 0 to the variable v of t times cv. Ultimately, you will have the equation half cv squared for the energy. If you write it as a function of charge, it's q squared over 2c. Okay? There is an example. We will start with it next time. We will stop here. So next time we'll start with the energy. Now at least we're back on track. Reminder, today's help session we will start with the Supernode and the Supermesh. We'll take some break and we'll continue back to the help sessions.
Which class were you?
It's going to be in 1001. Building 59.
definitely.
The exam, it's gonna be I think 1.5 hours. I don't know. 1 hour 15 minutes, 18 questions, something. We'll put announcements. في أحد ما حضر؟
في office hour today.
Yes, we will have office hour.